All right, YouTubers, this is a video that is nullifying the conspiracy theory and even the replies to the conspiracy theories about this anomaly that occurred on September 9th of 2018. Basically, a NASA video saw from a satellite that views the sun, it saw a large black object, almost the size of the sun, cross from left to right. Technically, it was kind of like this, but from left to right across the sun, and then about 3 or 4 hours later, another object looks almost identical but maybe slightly smaller went from right to left. So it just seemed really weird that some object could possibly go left to right and then right to left within 6 hours. Not 24 hours, but 6 hours. And so there's people thinking it's a Death Star. There's other people saying that no, it's actually the Earth and the moon crossing. I'm going to dispel both of those beliefs and show you that it's actually just the moon. So first, let's do this. Let's just talk about what I believe the right answer to be. It's kind of there's kind of three things going on here. The top part is all of the orbits with this large black dot at the top left. That's the sun. Here's kind of a depiction of what the satellite would be looking at. And then here is the graph of the velocities to give you kind of an idea of what's going on. So what I think is going on is it's actually in this kind of corner of the orbit. Let me kind of say this. So this is the sun, or the Earth, the sun. This inner orbit here is that satellite, which is at the geosynchronous orbit, 35,000 kilometers from the Earth. And then the outer one is the moon, which is, 384,000 kilometers. It is about 10 times further. Even though these look like they're really close, this line is actually 10 times further than this one is from Earth. So what I think is going on is this line that's pointing from here to the sun, that's basically what the satellite is actually viewing, because it's looking at the sun. And so what I think happened was the moon, or let me try to get this to focus. The satellite was slightly behind the moon while it's going around this corner. But what happened was, and this is not exact locations, but just giving you kind of an idea, it moved faster than this, and it basically passed it. So from this frame to this frame, the moon went to the right, crossing the viewpoint. So it went across this right here. As it kept going around the orbit, it stopped, the satellite stopped going this way and started going that way. And so as a result, its velocity dropped, and this thing was able to catch up with it, and it went from the right side to the left side, as you could see here. So it's like now the moon is crossing over from the right side, crossing across the sun. So looking at the velocity, at first the satellite is going faster, and this is velocity as a respect to going this way. Satellite is going faster than the moon. The moon it's either slightly increasing or it's just not going quite as fast. The satellite then crosses over and it starts going slower, and the moon speeds up and catches up with it. And at some point, it's going just enough fast enough, probably around this point here, that it's able to overtake that view of the sun. And then eventually the satellite is going at zero that way, because it's all going completely down, while the moon is still kind of going that way, but it's kind of doing an arc. So here's like the alternative viewpoint, and I'll go back to it another time, that maybe it was the Earth doing it. So the idea being that the satellite is on the back side of the Earth and it's viewing the sun. Well, again, you got to look at the perspective of the view here. As this thing circles around, this is technically, I just for my own mental sake, I switch the directions that they're going. It's irrelevant for reasons I'm not going to get into. It's just a perspective thing. It was easier for me to draw this way. As this thing goes this way, ignore the moon for a moment. As the satellite goes back behind here, you'll see the Earth will cross over this line from left to right. So the Earth could only go from left to right in this picture. And then if you look at the moon, it can only go from left to right from this picture as well. So you can't see this picture of going from left to right and then right to left, because you'd only be able to see left to right and then something else going from left to right. So that's kind of the first attack on that. Now, yeah, from left to right. So now, there's actually more to this picture, but now I'm going to just completely destroy that argument by getting into the actual math. So just for fullness sake, the diameters of the different bodies that are important: Earth, Moon, and Sun, 12,700 kilometers. That's how wide the Earth is. The Moon is 3,474 kilometers, and the diameter of the Sun is 1,391,000 kilometers. It's just so much bigger than these. It's an order of, what is that, like 100 times larger than the 1,000 times larger than the Earth? It's just massive. And so then the distances are kind of a very similar kind of thing. So same thing, this is the Earth. This is the geosynchronous orbit, which is at 35,000 kilometers. And then this right here is the orbit of the Moon. Then you got the Sun. So then these are all the distances. Distance to the Sun, about 150 million kilometers. Then the distance to the Moon, 384,000 kilometers. And the distance to the satellite, and this is all respective to the Earth, 35,700 kilometers. So one thing to note is just how big of a difference these distances are. And one to note is that the Moon is actually 10 times larger or further out than this geosynchronous orbit. None of this is to scale, none of my drawings. So then I also wanted to have the distances here, where if the geosynchronous satellite is on the opposite side of the Earth from the Moon, you have to add this distance to the... If you want to get the distance from here, from the satellite to the Moon, you have to add the distance from the Earth to the Moon plus the distance from the satellite to Earth. And that's what this big thing is here. And then when it gets closer, it's actually closer by that amount. I think in an earlier viewing of this, I didn't quite do this math right, or something just didn't seem quite right with it. But anyways, here's the point. So ultimately what we're doing here is we're attempting to look at the size relationship of the celestial body when you view it in space. So there's this belief that the Earth passed in front of the satellite. I knew that was just completely not possible just because of how close the Earth is and how big it is by comparison. My thoughts were, oh, the Sun is roughly about an inch big, the Moon's roughly about an inch big. But if you're not that far away from the Earth is like massive. It'll take up your whole field of view. So rather than just going with that argument, I decided to actually do the math. So this is in degrees, what was it called? Angular distance. So probably the best way, I drew this kind of diagram to get you an idea. So it's like if you're standing here, or it's a satellite or something like that, and you're viewing some big body some distance away, it's kind of like a triangle. It's actually a cone. So I guess if I turn it slightly sideways, it's not quite accurate. I started drawing it here where it goes up like this, and it's a viewing cone rather than a triangle. And so you're viewing, you got the diameter here, and then you got the distance. So the way to do the math here is for the Sun to the Earth. So the question is how big does the Sun look from the Earth? Well, you plug in the diameter divided by the distance, and then you times it by this kind of constant here, and you get 31.9 minutes. This constant right here, this is a conversion into the angular distance, and then I do this divided by 60 degrees because I'm getting it in minutes. So then I've got the Moon from the Earth, and I end up getting 31 minutes, which checks out. So the sun from the Earth is bigger than the Moon is, but just by a little bit. So then the moon, this is where it gets interesting. So the moon from the satellite. So at kind of a small size, it's about 28.4 minutes. And then I've got 29 here. I think this is wrong. It should be technically larger than the moon from the Earth. Yeah, it should be large. This number should be larger because you're closer to the moon. So, but you get an idea. It's probably like 32 or something. Earth from the satellite. Now, this is the one that's important. So, how big is the satellite when you view it from Earth? No. How big is the Earth when you view it from the satellite? 760 minutes or 12 degrees. In other words, it's 24 times larger than you view the sun. So when you see the sun out in the sky right now, imagine it's 24 times larger than that. That's how big the Earth would look to that satellite. So then, lastly, what does the sun look like from the satellite? I just wanted to get this. But because this number is so huge, it doesn't matter if the satellite is close or far away. It is basically the exact same size. No surprise. So here's kind of the wrap up of the relevant numbers. Sun, 31.9 minutes. The moon is 28 point, parent size of the sun. Parent size of the moon from the satellite. So when the satellite looks at the moon, it's as small as 28 minutes and as large as probably more like 32, not 29. And then the Earth from the satellite, when the satellite views the Earth, it's 760 minutes or 12 degrees. So the conclusion is the Earth never passed between the satellite and the sun. That's just not possible. So I did draw a scale going back to this belief that the satellite came back around, viewed the Earth, and viewed the moon. I've already proved that wrong because of the direction of travel. Now let's look at what it would actually look like. I drew it to scale. So imagine again, this is you right here is the satellite looking out at the sun. You've got this kind of tiny dot. This gigantic blob would be the Earth. So the Earth would just completely and totally encapsulate the sun. It would not even come close. Whereas the moon is basically just slightly smaller than the sun. So it's going to pass over and then it's going to pass back. Basically as shown by this right here. And that's it. That should pretty much wrap that mystery up.